So now, sorry, now we can go to some of the troubleshooting. We'll discuss about this more detail. So what are the key things we should know about? So this if you're looking at once you're decrypting and as well as when you're doing a handshake and if you're trying to analyze your packet, you have to look at the error. So it says, the Wireshark says it's a bad certificate. So you have to go to your TLS and you have to go to your record layer here. Here exactly it says server hello done. But if you look at this error in the record layer, the alert, it says exactly here, it says if there is a bad certificate, you will get an alert here. So they made it as a client and server name. So by differentiating your DNS entry, as I told, we know what is the destination I'm reaching. And here I can say, this is my client and this is my server. With the DNS option, you can use it. It's pretty handy to use. And if you got your expired, if your certificate is expired and your TLS handshake fails, then in the same record layer, you have to go to client hello. In the same record layer, you can see your certificate expired message there. It's a fatal error and you can verify. And if you look at this is client, this is server. So here it says, I don't know who is your root CA is. In the same record layer, you can go and it says unknown CA. You have to check your cert there. So here it says handshake failed. So here the handshake failed because the server only supports RC4 MD5, but I don't have that. So it says it's a fatal error, the same record layer, it's a handshake failed because of encryption. So I don't own that particular algorithm in my cipher suite. So you can look for all these errors and you can check the same. See, it says it's a protocol version mismatch. It's a certificate expired and it's a handshake failure. So as I told you, the very first thing is my TCP handshake should be successful. Then your client hello. Then I should receive a server hello. And the client will do a client key exchange. And I should receive the same server key exchange. And once the data transfer happens, it should successfully close the connection. So the FIN packet, it says that I'm closing my connection here. So this is how you can troubleshoot your problems. This is the most common problems you will face. And with this, and if you decrypt your packet, you got more information on it, and I'll go through that. Now, it's the same thing, we'll try to do a live decryption, but sometimes if my pre-master, I couldn't find my pre-master, then it is difficult to do it. So that's why I got this capture. This is successfully decrypted. Now let's try with the new capture. So I see only the UDP communication happening here. I see a few packets for TLS. So this is how generally it should see. If I don't have the pre-master key, this is the only information I can see there. So for that, let me go and check. Is it my keylog file is enabled? It's not enabled here. So I have to specify. So you can create your own profile here. Sorry for that. So you can create your own profile and you can add your profile. But now we are going to use the existing profile, protocol, TLS. To desktop SSL key. You can see the SSL key file is incrementing. So I'm going to remove this filter. So this is my WhatsApp chat. I logged in my browser. So if I go to conversation filter TCP, I don't see the client hellos here. Okay, I can see that. I don't think we got the pre-master secret. Let me check one more time. Is it my protocol? TLS. It's there. So let me try to establish a connection. So there. Where's my Zoom? One minute, I'll share it again. This is my edge. So I think Mozilla was better. So if I try to go to youtube.com, DNS contains YouTube. Go to my DNS. So I don't have my name resolution enabled here. Resolve network IP address. Okay. Why is that it's not resolving my DNS? It's bing.com. So I establish a connection to youtube.com. So somewhere the youtube.com. I say only DNS. this is query response. So see only DNS because that is the DNS server. I'm trying to find a server. Okay, I see here. Let's follow the stream. But our session should be established successfully to see that. Copy a value. I don't think we can do it. So it's a Microsoft, okay. Do I see any traffic for it? Go back here. So I see connection going to conversation filter TCP. So client hello, certificate I see. So okay, for the same packet, if I go and disable it. I think the decryption has been done. So it's showing up that. My connection is freezed. Encrypted handshake message. Edit preferences. Go to protocol TLS. There is no information now. Let's stop this capture. It's very choppy. Let me open up a new one. Okay, now let me go try something else. Microsoft.com. Sorry for that. I got network issue here. So the traffic is going to Microsoft. I should see DNS complaints. So React, Internet. Why it's not coming up? So I see the resolved address for Microsoft. Some random address here. DNS dot query equal. Is that command? Oh, no, let me check. DNS query filter. Microsoft.com. So this is the destination. So IPv4.destination. So if I give IPv6 dot address equal. So this is again only the DNS server details I'm getting. So I'm trying to find the traffic for this. Microsoft. So all application data. No, this is a problem I had even when I tried for a capture. Sometimes if I couldn't find the pre-master key, then I couldn't decrypt. But there exactly for few website it works. And it should work. Sometimes it could be a problem with the browser because in some forum they suggested the browser, but I tried the Mozilla for the same for the successful decryption. It worked for this particular website. And I'll come up with a solution for it. So if I give my pre-master key here, and if I filter for yeah, I can see this data for this. I look for an option for the same, but the key thing is you have to have your pre-master secret. Otherwise you cannot decrypt your data. And I tried with Mozilla, it worked, and Chrome and Mozilla both are suggested. You can also try with this capture. And with the troubleshooting steps, whatever we have here, it would be helpful for you to figure out where the problem is. And for this pre-master secret, I'll come up with a solution in the next class. And for now, this is how we can decrypt. So we have seen the steps, how we going to decrypt it and what is the pre-configuration I have to do from the PC as well as in the Wireshark to do that. And it is always suggested to use the name resolution filter because that would be helpful for you to resolve your names. That's helpful for you to track your information. Instead of names, you get your DNS names. That is very helpful for you. And now then let's discuss today how well you guys understood about TLS handshake. And based on that, I'll give you, even more details. So I don't want to confuse you with the dump, and it's not like more information in a single day to get confused with TLS. So this gave an idea exactly how the Wireshark is decrypting the packet and what are the information I can see. The main key takeaway is how this TLS handshake happens, what is exchanged in client hello, what is exchanged in server hello. So the version that's been exchanged, then along with that, the cipher suite that's exchanged between client and server, and it should match. And if you see a fatal error for your expired certificate, you can see that. And as well as if you got your, if it doesn't know about your certificate authority, it's going to report as an alert that I don't find your certificate authority and I cannot trust it. So with those capture, you can figure out that. And along with that, we discussed about the certificate expired. And when you do a decryption, you can actually see your layer 7 information. So what is the layer 7 protocol that's been used? And even I can see inside the server information, I can see which particular servers I'm talking to. Whereas without decryption, you cannot get those details. So the very first thing is you have to establish a successful TLS connection with the server. Only then your pre-master key will be stored in your key file, the pre-master key file. That helps for your decryption. And this is you can take a close look about all this alerts and errors. That would be helpful for you to figure out where the problem is. And this is all the key things you should know. First thing, the TCP handshake should happen, then TLS handshake should happen. Only then your application data is being exchanged. And you should see the FIN packet, that is your TCP connection is closed. So all your TLS is encrypted, and both client and server, it maintains two tunnel, one from client to server, another one from server to client. And all this informations are encrypted and exchanged only between the client and server. That is about the quick overview about SSL handshake. So we call this as a TLS handshake. And we have a couple of details, more details inside. This is too deep. It's about deep dive about TLS handshake. But for now, I don't want to confuse everyone. So I want to give you a strong background about how exactly this exchange happens. And the main objective is how the Wireshark is decrypting this TLS handshake and what is the additional information you see from that. So for now, let me stop sharing and stop recording.